Today we're going to talk about some advanced JavaScript, or what this actually should be called is more specifically advanced async. So we've been using asynchronous things, we've been using the .then things whenever we send a get a post request. Before I move into more advanced usages of async, I want to make sure we're all crystal clear of why we actually need async again. So we're going to do a little bit of an experiment and see what would web dev be like if all HTTP requests were synchronous. So what do I mean by that? So here's how it is right now in Capcom. We have our .thens, which means this thing will execute asynchronously. So first step, it fires off the stories request. It does not wait for it to finish. Instead, it immediately continues on and prints out the request to some stories. Then some time passes, and eventually the request is filled, and it hops back up into this callback function and prints out story elements. This is what we've been using this whole time. So this should actually be familiar with you. But what if it was like this instead? If it was synchronous? So this code speaks for itself. We send a request to API/stories. It sits there and waits for it to finish. Then moves on to the second line, then the third line. So this method is a lot simpler. There's no callback functions. The code doesn't jump around in weird orders. It's a lot more easy to reason about. So what could possibly go wrong? Let's find out what could go wrong. I modified Capbook, made a new version where you can turn off the async. So basically that means all the get post requests will basically do this. It'll wait for the request to finish before it does anything else. Let's take a look. So Okay, so async enabled. You can turn this on and off. I wrote some sketchy deprecated code that will let you turn off async. So let's see. So let me just start this. I made one more change. So I want to compare the performance of synchronous versus asynchronous. So in order to do that, I had to kind of simulate running this over an actual network. Because right now the server is running on my laptop. But I want to simulate running it on a laggy network. So I added this new middleware called Slowify, which basically takes every get or post request and slows it down by 0.1 seconds. So it's not just like a massive delay, but it should simulate having a kind of net-like connection to the website. So let's take a look. So async enabled is still true. This is normal Capbook with a little bit of network lag. So I posted these 26 stories for every letter, just to demonstrate. So you can see it's not instant. It takes a second, but it's not that slow. You'll notice that all the stories show up, and then like a half second later, then the comments show up. So things kind of like load, like not all at the same time. So yeah. Okay. Yeah. Okay. So that's what's happening. Now let's try training it to disabling this function. Async enable equals false. Okay. So I'm going to log in. Now let's try to open up the home page. Click. Is there? Okay.
Is that what happens?
What is happening? Let me try this weird thing. Switch please. Okay. I assume that's better. Alright, so once again, click on home. There it is. So that took a while. But it's even worse now. Look what happens. If I click on home, so right now we got this cat image, right? Click on home. Doesn't work anymore. It's gone. The whole website is frozen up. It's completely screwed. And then it loads. So what is happening? Let's take a look at this network panel. So as you might remember from the whatever the heck it's called, the Facebook thing lecture, GraphQL. How do I make this? Here we go. So this will track all incoming network requests. So every time there's a request, it'll show up here. So this was the request to load the user. So I'm going to click on home page. Look at this. It's loading, it's loading, it's loading, it's loading. So every single little green line is one request for a comment. And it waits for a comment to finish before it starts loading the next comment. So it loads every story one by one in a perfect order. So this is synchronous behavior. So basically, that means to load every story, it takes like 5 seconds, because they all go one by one by one. And what's even worse, while it's waiting for a request to finish, we've turned up async, so JavaScript is not going to try to multitask anything. So that means it's also going to ignore any clicks that we make. So if I try to click on cat happiness, JavaScript's going to be like, no, wait a minute, I'm too busy handling this GET request. I don't care about your clicks, I'm going to ignore it. Yeah, so that's no good. Now, if I change this back to an async enable is true, let's try the same thing. One in. Let's reset this. Here we go. There we go. Async enable is true. So look at this. All these requests, this big chunk of requests, they all filed at about the same time. So instead of waiting for one request to finish before starting the next one, it multitasks and it fires off one request, says, I'm not going to wait for it to finish, so let's start with the second one. So it can multitask. And it can do this all while also listening to user input. So I can go back and forth between the tabs, and it'll always listen to what I'm doing, even though I'm spamming all these hundreds of requests, if you look at the bottom. So async is cool, because it lets JavaScript do some kind of multitasking, as in, yeah, basically, yeah. So, what did we just see? So, the synchronous approach, what we saw on the screen, is when we send a request, it has to go all the way to the server has to do stuff on the database, and then respond. And that might take a long time. And in between that, if we're synchronous, we're not doing anything. We're just sitting there. We're not even listening to the user. So the whole page stops responding. Like indeed, if you look at if I treat async enable false, if you look at the console here, oh, I have to wait for the page load, it'll take 20 years. Oh my god. Yeah, so like Chrome gets pissed at me. He's like, why are you using asynchronous requests? It has detrimental effects to the user experience. So it'll be like, what are you doing? Why do you have this enabled? Yeah, so it's bad. So, but if it's asynchronous, that means we fire up the request, we don't wait for it to finish. We start doing other stuff in the meantime. So I'm going to send out more requests. I'm going to listen to the user's input. I'm going to do other work. So the browser is not patient. It does not want to sit around doing nothing. So it tries to do some kind of asynchronous multitasking behavior by using this. So now that we have that established, let's go back to promises and talk about them more. So we kind of introduced promises a little bit abstractly. We said a promise is something that's like, I don't have data yet, but I promise I'll give it to you. And it's kind of vague, but actually what a promise object is something that just tracks the progress of your request. And a promise can have 3 different states to it. So a promise can be pending, which means that I requested some data, but I don't have it yet. I'm still waiting. Or it can either resolve or reject. So it can either succeed or it can fail. So a GET request, if it succeeds, it gives you back your data. That request is resolved. And if the server runs into some kind of errors, it might get rejected. So what if I did this? So we have a GET request, and we told you that GET requests have promises. So if you just print it out, it would just say in your console, this is a promise and it's pending, because it doesn't have your data. But if you waited some seconds and printed it out again, then it would say your promise is resolved, and I have your data. How do you know when a promise is resolved? We know this, you use .then. So .then is a function that gets called when a promise is resolved. So we send this GET request, eventually it'll work, and then it'll run this inside callback function. But what if it doesn't get resolved, it gets rejected? So we send the API request to stories, and maybe our server has a bug or something, so it crashes. In that case, the .then will not run, because .then only runs when a request is resolved. So how do we handle this? There's another thing, it's called .catch. So if we send something with a promise and it fails, if it gets rejected, then it calls something called .catch. So this will get called. And so as you see, you just chain it at the end of the .then. So you have a .then, some stuff that gets run when it succeeds, .catch, some stuff that gets run when it fails. So overall, the summary is this is how you use promises on the most basic level. You can use a .then on it, or you can use a .catch in it. The first one to handle success, and the second one to handle failure. Okay. So let's try to think about some more advanced usages of promises now. What if I have 4 things I want to do, but I want to do them in order? So I want to get data 1, after that's done, then I want to get data 2. After that's done, then I want to get data 3. This might be necessary in some applications where you have to do things in a certain order. Will this work? Obviously not. But what does this print out? Like, nobody knows. Like, it could print out 1, 2, 3, 4. It could also print out 2, 3, 1, 4. It could also print out 4, 3, 2, 1. Nobody knows. So this happens because we fire off all 4 requests at roughly the same time. Because after we fire off a request, we're not going to wait for it to finish. We're just going to move on and fire off the next one. So you've got 4 requests outgoing at the same time. And they're all racing to the server to see who's going to get resolved first. And this can be in any order. For example, say the request for data 1 is really slow. Like it has to go through a bunch of database queries and stuff. So data 1 might actually come out last or something. Maybe data 4 comes in first. There's so many factors that could affect which one of these prints first. We can't predict it. We can't rely on this. One thing you could do to force an ordering is something like this. Now this is kind of ugly, but try to process what's going on here. I get data 1. Once that's done, then I get data 2. And then I get data 3. This will always print out 1, 2, 3, 4. This is guaranteed because of this nesting behavior. So 1, then 2, then 3, then 4. But this is kind of ugly because you've got this big indentation stuff, and you've got this big cascade of brackets and semicolons and parentheses at the end. And if you have a bunch of tasks to do, this can get out of hand pretty fast, and you'll end up in a bad situation. Fortunately, promises will come to the rescue and have a more clean way of doing this. So here's the same thing. You can rearrange it like this. So this is called promise chaining. You can have a big chain of .thens that represent different promises without having to nest in different layers. So how does this work? So basically, when you have a promise, when you have a .then, and your .then returns another promise, then you can chain it and add another .then. So basically, I have my .then, I return another GET request, and then the response from this gets passed into the following then. Okay? So this is how you chain multiple things together. And it reads pretty intuitively. So get data 1, then get data 2, then get data 3. So that's how this works. But it's still a little bit annoying to type out. So we're going to, in a few minutes, show you a better way of doing this. But for now, let's talk about some other things you can do with promises. So the promise library has some other cool functions that might let you do cool things. So for example, let's say I don't really care about the order anymore. I just want data 1, 2, 3, 4, and I want all of that data to come in before I do anything with it. There's a function, promise.all. It takes a list, it takes an array of promises, and it will only call .then when all 4 of these things are resolved. So I send out my 4 things to the server, I wait for all 4 to get answered, and then I run this callback function. And then, as you can probably guess, all data 0 corresponds to the first request. This corresponds to the second request, the third and fourth. There's another one, probably a little less useful. So it's called .race. What if we so we fire up all 4 requests, and now you want to figure out which one is the fastest, and I want that data. I don't care about everyone else, they're too slow, they lost out. So I'm going to fire all 4 requests at the same time. They're all going to race to the server, and they're going to try to come back and get resolved as fast as possible. Let's say data 3 is the fastest one. It's the first one to get resolved. Then I'll print out data 3 here. What happens to the other requests? They get thrown in the trash. We don't care. That's one thing you can do. Set up a deliver phrase between a bunch of promises. You might not have an actual use for this, but that is pretty cool. But yeah, as I said, the promise chaining, that's pretty cool. It's still kind of annoying because we still got this weird callback syntax. But there is another way. There's a new modern JavaScript feature called async awaits. And it builds on top of promises to get you asynchronous behavior without using any callbacks. So what could this possibly look like? So here's what we have. So here's some example code with promises. So say I have a print stories function. All it does is it gets stories and it prints them out. The new async await syntax for this would look like this. This is doing about the same thing. So it's going to get a stories returns a promise. And the async await the async operator, or not the async operator, the await operator, what it does is it waits for a promise to complete before running the next line. So that means you can safely do something like this. You might be wondering, I just told you that synchronous is bad, so why would this ever be okay? And the reasoning is that I made the outer function an asynchronous function. So that means when we call print stories, we won't wait for it to complete. We're going to keep moving on to the next line. So it's okay to have a wait here, because this whole operation here is going to be async due to using this async word. So let's make this a bit more concrete. So if I have something like this, we can think about what this would print. So it would print out, first it would obviously print out A, then it would call print stories. But because it's async, we're not going to wait for it to finish. So we're going to print out B immediately afterwards. Then sometime later, the get request will finish and we'll print out story objects. So the expected output is A, B, then story objects. That happens because print stories is an asynchronous function, which means we don't wait for it to finish. Yes, this is the order. Now, let's think about something interesting. Can you return a value from an async function? So let's say I have a get stories function, it's an async. It waits for the response from the server and then returns it. Can I do this? Will this print anything? Will this work? What would it actually print out? It would actually print out a promise. This happens because get stories is asynchronous. So when we call this function, we don't want to wait for it to complete because it's going to take a while. So it has to do this get request. So what it's going to return is actually a promise for story objects. It's going to say that I'm not going to wait for this function to finish. It's supposed to return story objects, but I don't have it yet. So I'm going to promise I'll give it to you later. So one way to actually get story objects is, of course, to use the .then on it. So basically, the idea here is that any asynchronous function will always return a promise. So and any async function is thennable, right? So this works. It'll get stories. It'll run this function, which is asynchronous. And then sometime later it'll call this callback function. Or alternatively, you could just make the entire component amount asynchronous and use the await keyword. So this is also perfectly fine. So get stories is an asynchronous function. It returns a promise. And what do we say about promises? You can wait for a promise to finish by using await. So yeah. This will basically do the same thing. It'll wait for get stories to finish, and then store the result in story objects. And this is very powerful because you can replace the promise chaining things with just a bunch of awaits. So these are basically equivalent snippets of code where you take any chain of promises and you reduce it to a bunch of awaits. So first I'm going to wait for the first get request to finish, wait for the second request to finish, wait for the third, and wait for the fourth. And remember from promises, we had this .catch thing. Instead of a .catch, now we have a different syntax that you can use called try-catch. So you might have seen this if you've used something like Java before. But basically the way this works is it tries to run the stuff in these first two lines. If an error occurs, if a promise gets rejected or something, then it'll give up and run this in the cache. So this is kind of a lot. So I'm going to actually, first of all, let me mention that whenever I use await, it's been inside of another async function. And it's actually required in JavaScript that anything await has to be inside of async. Because as we know, doing things completely synchronously is bad. So we want to make sure that we're always using async behavior when waiting for a promise. So let's give a more concrete example to kind of solidify this.
Question.
Yeah.
So is the only benefit to this the syntactical simplification?
Yeah, basically async await is kind of just like syntactic sugar on top of promises. Like if you can do something with async await, you can do it with regular promises. It just makes it look a bit prettier and readable, generally. Another point is that if you have an async function and you're not using awaits, then it's kind of pointless because the whole purpose is for async and await to go hand in hand together. So if you have a function that's async and there's no awaits in it, you're basically kind of accomplishing nothing. So that's one thing to be careful of. Don't just put the async keyword everywhere in your code, expecting it to run faster. That's not how it works. So let's put this into practice a little bit. So I got catbook. I'm going to open up API.js in the server. So right now we're using these. Actually, let me turn off this. I'm on the branch that runs everything synchronously. Just off a minute. So right now we have this promise behavior. But what if I wanted to use async await instead? You can actually just make this handler an async function. Express will take that and be fine with it. And instead of using promises, I'm going to start over and say awaits this. So stories is equal to await. And then you just send it back. Right? That's all there is to it. So all this does is saying wait for stories fine to respond, and then send it back. That's all there is. And similarly, for post requests, we can make this an async function too. And then just say, like, for example, wait for the story to save, and then send it back. This is also fine. Right. We can also use async await in the front end too if you wanted to. So for example, what's a good example? Let's do this. Let's do the app. Let's do the who am I. So in app.js, we always call who am I in order to ask the server what my identity is. Let's say I want to use async await here. I'm going to make a component amount async. I think this is fine. React seems to be fine with it when I tried. So if you just wait for who am I, then so what I've done, so I'm going to wait for who am I to respond and save it into a variable. And then just run this code. So this simplifies the logic a bit, because now you don't have to look at callbacks. You just use the await keyword, and it'll wait for it to finish. But it's okay because this function is asynchronous, which means it's not going to hang up the browser and make the user experience garbage. So yeah, so overall, the way you might want to use it is, overall, you can use async in the front end if you want, by making the containing function async. You can also use it in the back end by making every get a post request route also async. One thing to be careful of is that Express won't let you make handlers asynchronous, but it kind of sucks at dealing with it when there's an error. If you were thinking about using async await in your backend, I might recommend checking out this article or coming to talk to me or something, because if sort.find happened to throw an error, what would actually happen is that it would just kind of crash and not ever tell the front end, so the front end just kind of be blissfully unaware that it ever failed. So you have to do some extra fancy things to make sure that error handling is still perfect. So one consideration if you're thinking about using this in your backend. Of course you don't have to. Yeah. So are there any questions about async await or promises? Okay. yeah, so overall, async stuff is good, synchronous stuff is less good because it makes the browser perform like trash. And reload promises can help perform async, but you can use this new async await syntax if you feel like it to make your code a little bit cleaner. Of course, async await is totally optional. It does the same thing as promises, basically. It just provides a nicer syntax. That might make your code more readable if you want to do that. Okay. So that is half an hour. That is what I have for advanced JavaScript. And before I move on, is there any questions about any of this? Any questions about other JavaScript features that you're confused about? Okay, yes. Oh, yes.
Other than debuggability, is there any reason you wouldn't always want to use this?
I think like pretty much I always use async await because it's mostly pretty like. I'm trying to think of disadvantage. Like sometimes try catches are kind of annoying. I don't know. Well, I mean, there's some times where so whenever you have to run async await, it has to be inside of an async function. But if I have something that's not inside a function, then you can't use async await. So I have to use promises instead. So there are a couple situations where you can't use async await. Like if I'm running code that cannot be inside of an async function, then maybe I need to use promises. But generally, when writing code, I don't really use much normal promises anymore.
I would say the only reason I ever avoid it is maybe error handling sometimes.
Yeah, and also
That's
there's
the main reason for me.
yeah, because sometimes it can be a little bit more unpredictable. Like as you see for Express, it doesn't know exactly what to do with errors when it gets it. But once you figure out the quirks, it's usually fine. That's it.